Okay, section 4.3c, we're still talking about solving quadratic equations by using the factoring method. You can see at the top of this notes page, we have our reminders again, the things that you are supposed to be doing before you identify which type of factoring problem you're dealing with. Okay, those things are to move all of your terms in your equation to one side, then make sure that the terms are in descending order. Then you want to make the lead coefficient positive, and finally you want to check for a GCF. Only after you have done those four things should you then look at the problem and decide which category your factoring problem falls into. Okay, so we're going to take a look at these three problems here on the front. You can see all of these are equations. So our initial step is to move everything to one side, and we're going to go ahead and rearrange it in descending order as we do that. Okay, so I'm going to bring the 2x to the left. I'm going to bring the 8 to the left so that it is all set equal to 0. I see that my lead coefficient is already a positive 1, so I don't have to worry about that. I'm going to go ahead and check for a GCF. I don't see anything in all three of these terms that I can factor out. So now I'm going to come down to my list of factoring problems here and decide which type of factoring problem this is. It's not number 1 because I never removed a GCF to begin with. It's not a binomial, so it can't be a difference of two squares. But there are three terms here, so it is a trinomial. In fact, it's this third option, the trinomial where the lead coefficient is a 1. This tells me that I should start by making one of those X charts. Okay, when your lead coefficient is a 1, this problem's a little bit easier. We don't need to use that factoring by grouping technique. You can kind of jump right to the parentheses. You can put an X at the beginning of each set of parentheses. A times C is -8. The B is +2. The two numbers that would multiply to be -8 but add to be +2 are +4 and -2. So this is how that would look factored. And then we take this one step further and we set each factor equal to 0 and solve for x. And we get our two answers of -4 and +2. Okay, let's go ahead and try the same thing here with example B. I'm going to move everything to one side of the equation. I'm going to make sure that it is in descending order. It looks like my lead coefficient of 12 is already positive, but I believe there is a GCF here that we could factor out. Okay, 12, 22, and 70 are all even numbers, so I can go ahead and remove a 2 from each of my terms here. Okay, so I'm going to divide each term by 2. It's important when you remove a GCF that you maintain that it's sitting out here in front of the problem. It should not disappear because in theory you should be able to redistribute it back in to your parentheses and get back to where you started. Okay. All right, now that I have done these initial 4 steps, now I'm going to figure out where does a 6x squared plus 11x minus 35 fall amongst these 4 types of factoring problems. Well, clearly this is a trinomial, and I can see that it's a trinomial, but the lead coefficient is not a 1. So this prompts me here that I need to use the method factor by grouping. Okay, so I'm going to keep that GCF out in front. I'm going to go ahead and upgrade the parentheses to a set of brackets, and then inside those brackets, I'm going to draw 4 blank lines. Okay. If you recall, the first term goes on the first blank, the last term goes on the last blank, and then we proceed with making one of those X charts where A times C goes in the top. Now, this is a really big number. A is 6 and C is -35. That means A times C would be the number -210, and the B value would be this 11 here. Okay, so we need to try to think through what are two numbers that are going to multiply to be -210 but add to be 11. Now you might be able to think of those two numbers pretty quickly and come up with it, which is great. The bigger this top number is, the longer it seems to take people to come up with the two numbers because there's more combinations of numbers that multiply to be, in this case, 210. Okay, now I've given you this strategy before. If you cannot think of the two numbers that would work for this, then simply take 210, split it into any two numbers that multiply to be 210, and keep going until you are left with prime numbers. Okay, and then organize those prime numbers in order from least to greatest, and you can play with different combinations to try to come up with the two that would add to be 11. Okay. Actually, the initial two numbers that I broke this apart into are the two numbers we would want, and that would eventually be you combining the 2 and the 5 together into a 10, and the 3 and the 7 together into a 21, and of course you would want the 10 to be negative so that they're adding together to be a positive 11. Okay? It does not matter which number you place where. So I'm going to go ahead and just put the 21 here and put an X next to it. Negative 10 there, put an X next to that. And the whole reason that this is called factoring by grouping is because our next step then is to group the first two terms and the last two terms together. Now here's where this can get confusing. The GCF needs to stay all the way out in front and separate. Okay, you're now going to remove a GCF from the first two terms that you grouped. It looks like we would remove a 3x from each of these. So you're going to divide each of those by a 3x, leaving behind 2x plus 7. And now we want to remove something from the second set of parentheses so that what we have left behind would then be a 2x plus 7. Looks like we should remove a negative 5. Remember, when you factor things out, you are dividing what's there by what you're factoring out. So you're going to divide these each by negative 5, and that would leave behind 2x plus 7. So we're almost there. Now that we see a 2x plus 7 here and here, we're going to treat that 2x plus 7 as if it is the GCF of these two terms, and that means we are leaving behind in parentheses the quantity 3x minus 5. Okay, if you catch what I forgot to write down here, I forgot to carry my GCF down. Okay, make sure that you're always maintaining that GCF there in the problem. Okay, however, when we go to actually set our factors equal to 0, we're only setting the factors that have variables or x's in them equal to 0, and then we would go ahead and solve each of these for x. That would give us one answer of negative 7/2, and then another answer of positive 5/3. Okay. Okay, once again, I'm going to draw your attention to the fact, because it tends to happen a lot in example C, when we see little problems the way that that's set up there, that sometimes we forget to pay attention to the directions. The directions are requesting that you use the factoring technique. It would be unacceptable for you to divide both sides by 3 and take the square root of both sides. Although mathematically that would provide you with the correct answer, it's not what the technique that's being requested is here. Okay, so we know with the factoring method, we are to move everything to one side, so the 192 should come to the left. It's in descending order. Our lead coefficient is positive. However, a 3 goes into a 192, so that means we can pull that out as a GCF. If you were to divide 192 by 3, that's where we get 64. Now I'm looking at x squared minus 64, and I look at my box here, and I say, ooh, here, this is a binomial. So there are two terms. They're definitely a subtraction, so it meets this difference requirement. Now I just need to make sure that these are two perfect squares. 64 is a perfect square, and as long as the exponent on my variable is even, that means that is also a perfect square as well. So I'm going to draw two sets of parentheses. I'm going to put a plus in the middle of one, a minus in the middle of the other, and then I'm going to take the square root of the first term, and I'm going to put that answer in the first spot. Okay, then I will take the square root of the second term, put that answer in the second spot, and I'm only setting the factors that have variables in them equal to 0. I get negative 8 and positive 8. Okay, one last problem that we're going to look at here. You're going to see on your worksheet a problem really similar to this example too, so please feel free to have this notes page out and with you when you are doing a problem similar to this. This looks like it's way more complicated than what it actually is. Okay, here's what this problem is wanting us to do. These are not equations. Okay, it says this is an expression. Here they give you this expression. Okay, and they go on and they tell you that if you were to factor this expression, it could be written like this. Okay. Now, notice if you look closely at what I circled in red there, though, look at the exponent on this 5x plus z. See how there's a little a there? They say a is a constant. That means that's a number, but they're not telling you what that number is. They want you to go back to this original expression. They want you to factor it completely and then reveal what you think that missing exponent should be. Okay, you have to show the steps for these problems. You'll notice all of these problems are very similar. So when you catch on to a little bit of a pattern, you cannot simply just write down, oh, I know what it's going to be. A would be, and then write down that. You have to show your steps to support mathematically how you're getting the answer that you get for A. Okay, so we're going to look at this expression. Here is all one term. Then we hit that subtraction sign. We get another term. Okay, we should always be checking for a GCF at the beginning of factoring problems, and I notice that these both have the 5x plus z to the 4th power in common. So I'm going to pull out a 5x plus z to the 4th power, okay, and that's going to leave behind a 25x squared and a minus z squared. So I'm going to write 25x squared minus z squared. Now, if I look at this, I notice, well, that doesn't exactly match what they said my answer should be. But anytime you remove a GCF from something, you should always examine what you left behind and ask yourself, can you factor that part any further? Now look at what this is. There are two terms. This is a difference because there's subtraction here. 25 is a perfect square, and these exponents on the variables are even. That means that this piece right here, that's a difference of two squares. We can take that and we can split that into two terms, putting a plus and a minus. Now, the GCF that we factored out, that quantity, make sure to keep that sitting in front. So I'm just going to copy that straight underneath here. Okay, then I'm going to do the square root of this whole first term. The square root of 25x squared should be 5x. And then I'm going to take the square root of z squared. That should be z. Okay, now again, look at my answer. I have 1, 2, 3 factors. This was telling me I should really only have 2 factors. So let's look a little bit closer because we're almost there. Here I have 4 of the 5x plus z's. And look how many I have right here. I have 1 of them. Okay, I know there's just 1 because if you don't see an exponent out here, you know that's to the 1st power. So we can take these two quantities and kind of mesh them together and say, you know how many 5x plus z's we actually have? We actually have 5 of those, and then we have this extra 5x minus z. Now what I circled there totally matches what they said my answer should be, except the A is a 5. So I'm going to say A should equal 5, and I'm going to box that in. You're going to have a couple examples that are exactly like this. They're just going to use some different numbers, but this is the strategy you need to use. You need to